Hello, welcome to Shedency Jamb Training Center. We're going to be discussing on gravitational field, electric field, and magnetic field. However, the key factor on this topic is field. Then let me start explaining what it means as we make progress. A field in physics, it refers to as a region in space where the force of attraction can be felt. However, we have three types of field. We have the gravitational field, the electric field, and the magnetic field. More so, in this lesson, the objective is every student should be able to define gravitational field, electric field, and magnetic field. State and apply relevant formulas. Identify correct SI unit and also have the ability to solve Jamb standard question. Field. Gravitational field is a region around a mass where another mass experiences force. Example is the Earth being drawn in a space now from one of the Earth, that is the Earth rotating in its orbit. It means it moves from one point to another and it keep its constant rotation. It means the Earth will not go out of course. If an object is being thrown upward, the object will still come downward. All this is gravitational field in place. However, gravitational field strength, we're now referring to the strength of that region under what gravity concept now. The gravitational field strength, we have the formula as G is equals to what? Capital F over what? M. Due to the mass, we have it as capital G M over R square. While we have its unit as Newton per kilogram. On Earth, our gravitational strength is 9.8 Newton per kilogram. More so, the formula for gravitational is given as forces between two masses, either mass 1 and mass 2. The formula is expressed as F if we're asked to find the force. So we're going to be using the capital G, which is it has a constant value, which is 6.67 multiplied by 10 raised to the power of minus 11 Newton meter square per kilogram square. Then we now have the value of our M1 and M2 over R square. However, the formula for gravitational force is what I just explained now. More so, we'll be able to use it in Jamb. So once they ask us find the gravitational force, we are using this one. Find the gravitational field strength. Then we'll now use the upper one, which is G is equals to small g is equals to capital G M over R square. Under the electric field, we are now focusing on the positive and the negative charge. Before they come together, there is a space in between them. That space is what we refer to as electric field before they are being connected. However, it means that electric field is a region around a charge where another charge experiences force. The field strength, which we can also refer to as electric field strength, is given by capital E is equals to F over Q. We also have the point charge formula, which is expressed as capital E equals to what? KQ over R square, where our K value of 9 exponential 9 Newton meter square per column square. The unit is Newton per column. Electric field property, things that can be associated with the electric field. Number one, the field line move away from positive charge. It means the charges will now be moving away from the positive while they will be going into the negative. the feed line move toward the negative. So don't forget this. They move away from the positive. They now move toward the negative. Also, it can be attractive or repulsive. Attractive, it's when they now what come together. Repulsive, when they now what move apart. More of that common in electrostatics problem. However, we focus now on magnetic field. Under this aspect now, we are focusing on magnet, the North Pole and the South Pole. Before we bring these poles together, we now discover that bringing the North Pole and the South Pole together, they now attract. But when we now interchange or we now change one pole, it becomes either the North and the North or South and South. It now becomes repulsive, meaning that they will not attract, but they will move away from themselves. So the middle, that is the center aspect, before they attract one another, it's what we now refer to as magnetic field. Take note of this. Under electric, we are focusing on the charges. Under the magnetic, we are using what? Magnet, the North Pole and the South Pole. However, magnetic field is a region round a magnet or current carrying conductor. In that aspect now, that middle part of it or center, it's what we regard to as magnetic field. We now have the magnetic flux density, which is denoted with capital B, which is implies with capital B is equals to the string conductor I over what? 2 pi r. That's the formula if we are asked to calculate the magnetic flux density. All the variables or parameters, they will give it to us. So ours is to multiply and divide it, where its unit is Tesla, capital T. More so, we have the properties of magnetic field. One, we can see strongest at the pole of a magnet. It means at that, like towards the middle, the attraction will be what? Higher than when it's moving far from it. Also, we have the field line, which is north and south. That is outer side magnet. We have the direction, which is being determined by what? Right hand rule. We have the filament right hand rule and the left hand. Also, we have it act on what? Moving charge, not what? On stationary. More of this, we can now compare the charges. We can now compare the charges where the gravitational field act on mass, which it have unit Newton kilogram. We have the electric, it act on charges, Newton per coulomb. We have the magnetic, that is the field, it act on what? Current or magnet. Its unit is Tesla. Electric and gravitational follows inverse square law, which at the bottom we now have what? A square root, which is a distance apart. However, let's take note of this. For quick practice question, our mind should now focus on the unit of electric field strength, the value of the small g on Earth, where its magnetic field strongest, where that is the location where the magnetic field will be strongest. Remember, we have explained at that pole. Also, we'll discuss answer during what classes. However, whatever question you have, you can like forward it for what? More clarity. Let's take note of this. Let's understand more of this what? The definition of these three concepts: gravitational, magnetic and electric. Let's memorize the formula so that in case we are asked in Jamb or WAEC or any exam, we can be able to recall and give the appropriate answer. Let's also pay attention to the unit. Very important. In physics, we don't joke with the unit. So whatever you are doing, you must be careful with the SI unit at the end of everything. More so, let's practice calculation question regularly. That's one thing that will help us even more. The more we practice, the more we study, the more we have chance to recall and not to forget. That is the beauty of physics. If you keep it for one day, it may keep you for a week. If you keep it for a week, hopefully for a year, it may forget you, it may abandon you. So please ensure you practice daily. That's how you would recall and be able to use the formula alright. Thank you once again, and together we make impact. This is SGTC.